All right, hey everyone. Our Data Plus project is called Assessing Germline Variations Among Black Patients with Early-Onset Prostate Cancer. My name is David, and these are my partners Sonia and Nia. And a brief intro of our project. Um, we're focused on prostate cancer, which is a heritable cancer of the prostate gland, part of the male reproductive system. And it is the most common malignant cancer in males, and multiple twin studies and genetic studies have demonstrated how prostate cancer is indeed heritable. And unfortunately, prostate cancer disproportionately affects black men who are more likely to be diagnosed, uh, more likely to die, and more likely to be diagnosed at a younger age with prostate cancer. And they're often underrepresented in prostate cancer studies as well. So ultimately, our project aims to examine the underlying genetic risk factors behind this is disparity of prostate cancer, and this table below kind of looks at the characteristics we're looking for in patients with prostate cancer for the study.
So our data was whole exome sequenced, and we derived it from the Metropolitan Detroit Cancer Surveillance System. Our data frame was mapped by variant, but one issue we had was that we had too many variants, and we wanted to look at those that were most relevant. So what we did was filtering. Filtering was the first step. We created a subset that looked at variants that were impacting protein function, most likely to be deleterious and pathogenic, had rare allele frequencies in the global population, and were not associated with benign phenotypes. Following this, we took these relevant variants and created contingency tables that showcased frequencies of patients as well as certain variant characteristics that measured severity of prostate cancer, like family history or likelihood that the cancer progresses. We used these tables to do Fisher tests. Fisher tests were run and we calculated p-values, confidence intervals, odds ratios. And then these values were used to develop a pool of the most relevant genes. So we had one primary mechanism of gene collection using these values. We looked at p-values less than 0.05 and where the lower end of the confidence interval was greater than 1 to find genes that were most likely to be relevant. We put this new group of genes through pathway enrichment analysis, and from here we determined which biological functions were overly represented in our data. Aside from looking at which pathways were highly represented, we wanted to know which genes and variants were most significant. So we sorted genes and variants by looking at a measure that combined p-value and odds ratio.
In our cohort, we found two main pathways that are likely related to prostate cancer. The ABC transporter pathway uses ATP to transport molecules across the cellular membrane. The other pathway is the olfactory transduction pathway, which is responsible for generating signals related to our senses. In terms of family history, we found that 4 of the 5 variants most likely associated with prostate cancer are found in a gene related to colorectal cancer. Like prostate cancer, colorectal cancer is hereditary. Based on Gleason score in our cohort, the most significant variants are found in genes associated with other cancers and immune responses. We hope scholars can use our research and further studies to advance our knowledge of prostate cancer in Black men.